Hi everyone, my name is Michael Suchik and I will be showing you how to solve problem number 17 from exam 2 of the 2013 Physics 240 course.
The first equation we have is force is equal to charge Q times velocity V cross magnetic field B. This describes the force on a moving particle with charge Q and velocity V in a uniform magnetic field B.
The second equation that we will use simply defines the magnitude of a vector as the square root of the sums of the squares of the components. So now with these equations we can substitute what we're given in the problem,
V equals V naught I hat, and force equals F naught over root 2 J minus K hat into these equations. So that will give us this this expression. So the next problem we'll need to tackle is this cross product. Now we should know that component crossed with itself will equal 0, but the trickier part is to find out the other two. So what we can use is this little diagram here. All that we need to know is that if we go in a clockwise direction, say I hat cross j hat, it will equal k hat. And same as j hat cross k hat will equal I hat. Now, if we want to say do I hat cross k hat, we have to go in the other direction, and that's going to give you the a negative magnitude. So we have I hat cross k hat would equal negative j hat. So first off, with the I hat term, this is actually going to cancel out because it's crossed with itself. This is going to be important later because this means that we cannot determine the magnetic field component in the x direction. And then if we go down here, you can see that I hat cross j hat will equal k hat, and I hat cross k hat is going to equal negative j hat. And now what we can do is we can separate the expression into its individual components. So we have f naught over root 2 j hat. We just distributed that over there. Is equal to negative q v naught bz j hat. Comes from this part and this part. And that'll simplify nicely to solving for bz is equal to negative f naught over root 2 q v naught. And then for the k component, we have negative f naught root 2 k hat. Got that from here and here. And that is equal to q v naught b sub y k hat, just from here and here. Sorry. And then solving for b sub y, we get negative f naught over root 2 q v naught. Okay, now we can solve for at least the lower limit of the magnitude of the magnetic field. Remember, we could not find b sub x because the velocity of the moving particle was in the I hat direction, and I hat cross I hat from the magnetic field is just going to equal 0. So we won't be able to know what that component is. So if we come over here, we get the magnitude of the magnetic field is greater than or equal to, because this is the lower limit, the square root of those of the sum of the squares of the last two components that we found here. And doing some algebra, we eventually get down to here, and finally to the answer we want, which is b is greater than or equal to f naught over q v naught, which is answer C. And that is how you solve the problem. Thank you very much.